My name is Sydney Adamczyk, and for my project, I analyzed the impartiality of the scheduling procedures of the National Hockey League, or NHL. Since these schedules are decided upon by the league and not the teams themselves, it is important that no team is given unfair advantages and that competitive integrity is maintained. This is the schedule breakdown. So 32 teams are divided into two conferences, the East and the West, and there are two divisions per conference. Of the 82 games played, 26 are played against teams in the same division, 24 against teams in the other division from the same conference, and 32 against teams in the opposite conference. The NHL tries to structure the schedule so that back-to-back games are minimized and road trips, or stretches of multiple away games in a row, are well balanced, and each team will usually play against each other at least twice, once as the host and once as a visitor. So I asked how game location and time between games impact NHL team performance. If either factor is statistically significant, it would indicate an issue with the way the schedules are curated. So there are two factors of interest in this experiment: game location, or whether the teams played at home or away, and days between games, ranging from 0 to 4 or more days. I took data from the most recently completed regular season, which at the time of analysis was the 2023-24 regular season, and the response metric used was point percentage, or how many points the team earned out of the possible points they could get. Teams get 2 points for a win, 1 point for an overtime loss, and 0 points for a loss in regulation. So the possible points will always be 2 times the number of games played. Because of the way schedules are designed, most games are played with a one-day break in between, so there is more of an opportunity to earn points in that scenario. Thus, points percentage was chosen as the response metric instead of just points to account for this distribution inequality. Playoff status was incorporated as a blocking variable since teams who make the playoffs are more likely to have higher points percentages, and, as indicated before, teams will play other teams from the same conference more often, so this is accounted for in the randomization procedure. Within certain parameters, 4 teams were randomly chosen. 2 were selected from each conference, and of these teams, 1 made the playoffs and 1 missed the playoffs. With the levels of each factor of interest, this resulted in 40 observations of the response variable, or 10 per team, and the design matrix is shown to the right. Here I have 2 versions of the same graph taking different factors into account. On the left, point percentage is plotted against time between games with respect to game location, home being 0, 1 being away. There is no apparent trend of home or away games resulting in a higher points percentage, nor does there seem to be a trend among the time between games. However, the within-group variation is heavily apparent, with the least variation at the 1-day level and the most being at the 4 or more days level. This is expected because of the inequality in frequency of games played with a certain number of days in between, leading to less homogeneity in the variation across the levels. The same is true for the graph on the right, which takes playoff status into account. While it can be argued that teams that make the playoffs have higher point percentages, the within-group variation makes it difficult to discern visually. The ANOVA table generated reflects similar sentiments to the graphs. Neither factor of interest has a discernible effect on point percentage, nor is there a discernible interaction effect, as indicated by the p-values of 0.908, 0.608, and 0.683. Playoff status, while also not significant, had the lowest p-value at 0.113, so it is possible that more data would result in this value decreasing to a statistically significant degree. The error sum of squares is also much higher than the sum of squares of any of the other factors, meaning that other factors that were unaccounted for have more of an impact on point percentage variation than those explored here. To summarize, there is not enough evidence to reject the null hypothesis, so for the teams chosen and the year observed, it is reasonable to conclude that the NHL schedule is generally fair and balanced. However, because it was conducted on such a small scale, this experiment is limited to what it can tell us about the scheduling procedures. Resources allowing, it would be beneficial to see how pulling data from more teams or from additional seasons would change the results, and doing this would keep the NHL in check and ensure that team performance is not impacted by factors that the teams cannot control. Here are the sources I used, and thank you so much for listening.